Okay, today we're continuing our discussion of conditionals. We're going to be looking at nested conditionals, and then we'll look at private methods, which seems a little unrelated, but it'll all tie together. Okay, so starting off with nested conditionals. Nested conditionals are not anything new. So last time we looked at the if statement, we looked at if else, and we looked at if, else if, else if, else if, dot, dot, dot. So nested conditionals are not a new conditional structure. They're just a new way to use the conditional structures that we talked about last time. And that is that you can put one conditional structure inside of another conditional structure, hence the nesting. So here's an example of nested conditionals, and this method takes in three integers, num1, num2, num3, and it returns the minimum of those three numbers. And I'm going to show you different ways that you could write this method because, again, once we hit conditionals, there's really no one way to write your code. There's almost always multiple ways that you can structure your logical code, and it kind of comes down to which is the most concise or which is the easiest to read, so on and so forth. So we'll look at different versions of this code. Okay, so here we have one implementation. You can find this also in your textbook. So this method is taking in three numbers. Here we have a local variable called min. That local variable is going to record or store the minimum that we found so that at the end we can simply say return min. Okay, so here we're starting off with our first question, our first check, which is number one strictly less than number two? Okay, if that is true, then we're going to go inside this if statement here. And if you look inside the if statement, we have another if statement. Okay, so that's where the nesting is coming into play. So if number one is strictly less than number two, and if number one is strictly less than number three, it must be the case that number one is the minimum, and so we will store number one in our local variable min. Else, it must be the case that number three is the minimum, right? So we know once we get inside this if statement here, we know that number one is less than number two. So at that point, we know that number two cannot be the minimum. It's either going to be number one or number three. This inner nested if else statement is deciding between the two. Is it number one or is it number three? So if it's not number one, then it must be number three. Similarly, kind of backing out to the outermost if else. So if number one is not strictly less than number two, then we know that number one cannot be the minimum. Okay, either number two is smaller than number one or they're equal. Okay, so this else here, so this is the else statement. This is the case where number one has been eliminated, and now we just need to decide between number two and number three. Okay, so if number two is smaller, set our local variable min to number two, otherwise set it to number three. Once this piece of logic is done, we know that the variable min stores the minimum of the three values, and we can return it back. Okay, so here's an example of solving this using nested conditionals. We have one conditional structure nested inside of another. Now, in terms of nested conditionals, you can do whatever you want. So we could have, depending upon the problem you're solving, you may be nesting 3 deep or 4 deep. You may have, nesting going on in the else, but not the if, so on and so forth. The only thing I'll say is that after a while, the human brain starts getting annoyed if you keep nesting. So it's okay to have here, right, we've got, I don't know if this is a depth of 2 or a depth of 1. Whatever, we're nesting to like a depth of 2, right? We've got like the outer if, and then we've got the inner if. So it's kind of like 2 levels or 2 layers. You could probably get away with 3. Around 4, that's when people maybe are going to get angry at you who have to read your code, and you may get angry at yourself when you go back and have to read your own code. So just a word of caution with nested conditionals, at some point, stop nesting. It just becomes confusing. Okay, so Let's just quickly run through this code with some inputs for number 1, number 2, and number 3. And I'm kind of abbreviating from num1 to just n1 just to save some writing time. Okay, so let's say that let's just pick 3 random numbers like 10, -5, and 0. Okay, and let's step through this code, assuming that these are the actual arguments passed into the formal parameters. Okay, so number 1 is initialized to 10, number 2 is initialized to -5, and number 3 is initialized to 0. Okay, so is number 1 less than number 2? No, it's not, so we would come down here. Is number 2 less than number 3? Yes, it is, so we'd go in here. Minimum would be set to number 2, which is -5, and we would return that back. Or we could say, what if we had like 10, 100, 10? Okay. So is number 1 less than number 2? Yes, it is. 10 is less than 100. So we would go inside of the if statement. Is number 1 less than number 3? No, it's not. 10 is not strictly less than number 3. So we would jump down to this else statement and we'd execute this. So minimum equals number 3. We would store 10 in minimum. Then we'd hit this closing curly bracket. That closes out this inner conditional. Then we'd hit this closing curly bracket. This closes out the if. And we would skip over the else. And we would return 10. Okay, in particular, once this is true, number 1 is less than number 2, we're going to execute the code inside of the if statement, and we are done. We would not then execute the code inside of the else statement. So just making sure that's clear. Let's see what would happen if they're all equal. Let's say they're all 30. So you should pause this video and step through this code and figure out which of these min equals, which of these assignments to minimum would be executed if they all were the same value. So we'll just pick 30. Okay, so you should like pause the video and make a prediction. Which of these which of these statements here storing a value in min will actually be executed? Okay. Okay, so let's step through and assume that num1, num2, num3 are all 30. So we would say, is num1 strictly less than num2? No, it is not. That brings us down to this else statement. Inside the else statement, we find another if statement. So is num2 less than num3? No, it's not. That brings down to this else statement. And we would store, right, minimum equals number 3. So we would store 30 in minimum, and then we would return back 30. So if they're all equal, we kind of end up in the else inside the else, right? We jump to the else, and then we jump to the else inside that else, and that's what's executed. Okay, so here's an example of using nested conditionals, and I want to now show you different ways that you could write this method. And I guess the first thing that comes to mind for me is what we talked about last time. Sometimes, not always, but sometimes you can use the return keyword to force a return from the method, and that allows you to simplify your conditionals. So on the right-hand side here, I'm showing the same logic. So this piece of code finds the minimum of 3 integers, but I'm using the return keyword. So the first thing you'll notice is that I don't have a local variable min anymore. I'm not going to store the answer in a local variable. Instead, as soon as we find the answer, we will return it back using the return keyword. So there's no need for a local variable. So if number 1 is less than number 2, we will go inside of the if statement here. Inside, if number 1 is less than number 3, at that point we know that number 1 must be the minimum, so we're going to immediately return it back. Because I'm immediately returning it back, I don't need an else statement. I can just say return num30. The only way I will get to this line of code here where I'm returning num3 is if this statement here, if num1 less than num3 was false. Okay, if it was true, I would have hit this return and then we would never execute the rest of this code. So we're guaranteed we're only ever going to get to this return statement, return num3, if num1 is smaller than num2, but num1 is not smaller than num3. Okay, and if you think about that, num1 is smaller than num2, but it's bigger than num3, so then num3 must be the minimum. Okay. Similarly down here, so if num1 is not strictly less than num2, we jump down to the else statement here. We check, is num2 strictly less than num3? If so, we return num2. Otherwise, we immediately return num3. And again, that logic is the same, right? So we would only ever get to this line of code here, right? We would only ever return num3 if num2 is bigger than num3, right? This if statement, this Boolean expression is false. So this is very similar to the withdrawal from your bank account method, where we can use the return statement to reduce the number of logical statements that we need. Basically, we're using the return statement to kind of direct the path of execution or the flow of execution. And that allows us then to simplify our code. Last but not least, I'm also showing here that we don't actually even need to nest conditionals. So if we look at our original code here on the left, I'm going to read this to you again. And maybe as I'm reading, you can listen and you'll hear that I'm actually reading off a Boolean expression, right? If num1 is less than num2 and num1 is less than num3, return num1. Okay, so even just from me reading it, you can hear we actually don't need nested conditionals. We can build a more complicated Boolean expression, which will get the job done. And so that's what I'm showing here. So again, I've abbreviated num1 to n1, num2 to n2, num3 to n3, just to save space. So again, we wouldn't need a local variable. We could say if n1 is less than or equal to n2 and n1 is less than or equal to n3, return n1. Else, so if we make it to this else statement, we know that one of these was not true, right? Either n1 is not less than or equal to n2 or n1 is not less than or equal to n3, right? We don't necessarily care which one of those wasn't true, but if we make it past that if statement, we know n1 was not the minimum. And that's probably the most important piece of information we can deduce. Okay, n1 must not be the minimum. So now we're choosing between n2 and n3. So now I'm going to ask the same series of questions for n2, right? Is n2 less than or equal to n1? And n2 less than or equal to n3? If that's true, n2 must be the minimum, and we'll return that. If it's not true, we have an else here, and that else will return n3. Okay. Okay, some last observations. We actually don't need this else here. Okay, again, we could just say return n3. Also, there's kind of differing opinions as to which of these two methods is better. Is it better to have a local variable min that holds the answer and you will set the value of min inside your conditionals and then have a single return statement at the bottom? Or is it better to remove the local variable and immediately return when you find the answer? And you'll find differing camps in terms of people's programmers' opinions. One thing to note though, and let's go back a slide here. So on the right-hand side where I'm immediately returning, we have 4 return statements, returning number 1, number 3, number 2, and number 3, right? So here, 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 and here. And a lot of people will make the argument that in a method, you should only ever have 1 return statement. And the reason why is as soon as you have more than 1 return statement, it's not clear when I'm reading the code, which of these return statements is going to be executed. In particular, it depends upon the inputs. So you've introduced a sort of variability, or you've introduced a sort of randomness to your code that can make it harder to debug and make it harder to understand. Whereas on the left side here, where we only have 1 return statement, no matter what you input, no matter what value num1, num2, and num3 are assigned, we know that this method ends right here, return min. And there's never a question about where is the method returning. So I knew a programmer once who really was like totally against having more than one return statement in a method. I tend to be a bit more permissive, but I want to show you that again with conditionals, there's always, almost always more than one way to solve it. And it kind of depends upon which is more natural to you. And also, you know, there are some kind of guiding principles, like you should only ever have one return statement. So, okay, so that's nested conditionals. I just wanted to show you, make sure that people are aware that you can nest conditionals. Your book also talks about that. Let's move on to private methods. And this example is going to use nested conditionals again. Okay, so what I want to do is I want to look at a piece of code that I've written, and this piece of code implements the following flowchart. This is a flowchart I found online years ago, so the numbers are probably wrong at this point. But basically, the question is, do I need to file taxes? And I remember when I was a college student, that was always a question I had because I was working a work-study job, so I was getting some amount of money, but it wasn't a lot, and I never kind of knew, oh, do I need to file taxes or not? And no one wants to find out that you owe the IRS because in college you didn't pay like 20 bucks in taxes on your meager earnings. So this flowchart is meant to help you decide, do I need to file taxes or not? So the flowchart begins at the top, and in the first question you would answer is, are you married? And if the answer is yes, then you're going to follow the flowchart to the left here. If the answer is no, you're not, then you would follow the flowchart to the right. Okay, if you are married, the next question is, are you and your spouse over the age of 65? If the answer is yes, then the next question is your combined gross income more than 30,000? Right, so together the amount that you make before taxes, is it greater than 30,000? If the answer is yes, then yes, you do need to file taxes. If the answer is no, then no, you do not need to file taxes. So the turquoise yes and no are your answers to the question, whereas the red yes and no are the final decisions from this decision tree. Yes, file taxes. No, you don't have to. Okay, if you answered no to are you and your spouse over 65, then the question becomes, okay, maybe both of you aren't over the age of 65, but is one of you over the age of 65? If that answer is yes, then we asked, is your combined gross income greater than 27,000? If the answer is yes, then you have to file taxes. Backing up a little bit, if neither of you are over the age of 65, then we ask, is your combined gross income greater than 25,000? If the answer is yes, then you do need to file taxes. So there is a high threshold on your combined gross income if you're older. But the younger you are, the lower the threshold becomes. In other words, the younger you are, what did I say? I don't remember. The younger you are, the higher your threshold. In other words, the younger you are, the more likely it is that you will have to pay taxes. Okay, so we kind of are giving a break to people over 65. Okay, that whole left half here was if you were married. On the right half, it's if you're single. So we'd say, are you over 65? If you are, then is your gross income greater than 27,000? If you answer yes, then yes, you must file taxes. If you are not over 65, which is most of you in the room, then the question is your gross income greater than 24,000? I think it's actually like 24.5 or something. And if the answer is yes, then you do need to file taxes. So these numbers are not up to date for this current tax year. This is like years out of date, but there is some flow chart out there that will help you decide, do you make enough with work study? I highly doubt it, to file taxes or not. Okay, so let's say that we wanted to write a program that is going to use a scanner. We will ask the user of our program these questions. We'll use the scanner to read in their answer, and then we'll kind of navigate through this flowchart, and at the end we'll give them the final decision, yes or no. Okay, so this is going to involve a lot of nested conditionals. In fact, basically each of these subsections is its own set of conditionals, right? So we have like the overall conditional will be like, are you married, yes or no? If you answer yes, and inside of their nested, we're going to have another set of conditionals. Okay, so the structure of this flow chart is mirroring the structure of our conditionals. Okay, okay, so here is what I called tax helper. Okay, and you'll see I already have counted. This main method is 78 lines long, so it's a pretty long main method. This is probably the longest piece of code we've seen so far. Up here I have a welcome message with some language about how this is not professional and I am not guaranteeing the truth of these results, so do not sue me. Always good to have. Okay, so here's our disclaimer up here. Then we're creating our new scanner and we're asking the first question, which is, are you married? Notice that I'm including, when I ask the question, I'm telling the user what sort of response I want back. If you just say, are you married, question mark, people are going to type the most random stuff. Yes, with a capital Y. Yes, with a lowercase y. Yes, all caps. Yes, all lower caps. Some people answer in sentences. Yes, I am married. So anytime you're writing a computer program, you want to give the users as much explicit feedback about the type of input you're looking for so they don't crash your program. So here I'm explicitly saying, hey, type yes or no with all lower caps. Okay. So then we're using next line to read in their answer. If the answer equals yes, we're going to enter here. So you can see this is pretty big. This corresponds to the part of the flow chart where both, where you're married. Okay, so what I've highlighted here is all of the logic, like, are you both over 65? Is one of you over 65? So on and so forth. So that's that. If you answer no, then here's the code for single people. Okay. Okay, so jumping back up here, if you answered yes, so you and your spouse are both over, sorry, you are married. So here. So if you answered yes, you're both married. Then the next question is, are you and your spouse over 65? We use the scanner to read in your answer. If the answer is yes, here we go. Right? We're asking if your combined gross income is more than 30,000, and then we're making a decision. If your answer is no, we need to determine if one of you is over 65. So that's this question here. System.out.print is one of you over 65. We scan in the answer. If the answer equals yes, right, here's the final decision. If one of you is over 65, then we want to know if your combined gross income is more than 27,000. If the answer is no, so neither of you are over 65, then we're interested if your combined gross income is more than 25,000. Okay, so that's this part of the flow chart here. Okay, if you're single, then we ask, are you over 65 years of age? We read in the answer. If the answer is yes, here's that code. If the answer is no, here's that code. Okay, so this is just a direct implementation of that flow chart using nested conditionals. Okay. Okay, this is a really long main method. And so what I want you to do is you're going to pause the video and I'm going to strategically like center this code. Okay. One of the reasons this main method is so long is because we have a lot of repeated code. Okay, so we have a lot of code. Maybe it's not identical, but we've got a lot of lines of code that are almost identical, and we're just repeating them again and again and again. So what I want you to do is I want you to pause the video, stare at this section of the code, and draw a box around where do you see the most repetition, right? What chunk of code is repeating again and again and again and again and again? Okay, and then I'm going to show you how we can pull out that repeated code and what it would look like. Okay, so pause the video. What chunk of code is repeated again and again and again? Okay. Okay. let me see. If I look at this code, I see a lot of repetition actually. So I'm just going to go through and highlight all the repetition. And then we're going to slowly start pulling out the pieces of repetition into methods. Okay. So the first thing I see repeated again and again is this. System.out.print. So we print something. Then we say answer equals input.next line. And then we check if the answer equals yes. And then we do it again. We print something. Answer equals input.next line. And then we check if answer equals yes. And we do it again. System.out.print. We print something. Answer equals input.next line. And then we check if the answer equals yes. Okay, so that's the first part that jumps out to me is logically that series of steps is something clearly we need to do again and again and again. Clearly. So what I'm going to do is I'm going to make a method. This method is going to print a question, it's going to read the answer, and then it's going to return true or false, depending upon whether that answer was yes or no. So basically, I'm going to take the functionality of these 3 lines of code that we see again and again, and I'm going to isolate that in its own method. Okay. Okay, so I'm going to make this method private. Private static. It's going to return true or false. That's a Boolean. And I'm going to call it is yes. Now, in order to execute this functionality, there's some information we need to pass in. The first thing is the question. What question do you want to ask? So one of the inputs is going to be the question. Okay. If the user passes in the question, we can then print it. Then the next thing we need to do is we need to scan the answer. And that means we need to have access to the scanner in order to do that. So my next input is going to be the scanner itself. I claim that those 2 pieces of information, the string question that you want to print and the scanner so that we can scan the answer, are the necessary and sufficient inputs to get the job done. They're both necessary. I need both of them, and they're sufficient. I don't need anything else. Okay, so when you're thinking about writing a method, that's the question. What's the necessary and sufficient pieces of information I need to get the job done, right? I need this and I don't need anything else. And that will tell you what your inputs have to be. This is also the first time we've seen that you can pass a scanner around, right? A scanner is just a variable input. And so we can definitely pass that to different methods. Okay, so let's take this logic here. So first thing we do is we print the question. So let's print question. Okay, then we are going to read in the answer. String answer equals input.next. Then the next thing we're going to do is we're going to ask if the answer equals yes. I'm going to create a local variable to hold that. So Boolean is yes equals answer dot equals yes. Then we're going to return back whatever value is stored in the variable is yes. Okay, a few things I want to comment on. First, this is a great method. It does exactly what we want it to do. How would we use this method? So this allows us now to replace some of the code down here. Okay, in particular, I don't need this anymore. I don't need to print, are you married? I don't need to read in using the scanner, and I don't need to call dot equals. All of that has been subsumed by this method up here. So the way it would look now is we can actually nest inside of this if statement. You can say if is yes, and now we need to pass in the question that we wanted to ask, are you married? We also need to pass in the scanner. And there we go. Okay. So I do have an error here because it's saying this variable answer was not declared. I just deleted its declaration. That's okay because we're going to go through and get rid of all of this. Okay, so in fact, let's do that. So, okay, so now we say if is yes, are you married? Then go inside of here. Okay, so when the computer executes this line of code, it needs to evaluate the Boolean expression. The Boolean expression is itself a method though. So it's going to jump up here. It's going to pass in our question, are you married? And it's going to copy that into this formal parameter. It's going to take input, which is just a memory address, and copy it into this variable. It's going to execute, so it'll print the question, read the answer. If the answer is yes, this will be true. If the answer is no, this will be false. Okay, and whatever that is, it will return it back. So this whole method call resolves down to either true if the person typed yes, or false if the person typed no. Okay, so when we resolve this method call, this entire method call just gets replaced with either either true or false, depending upon what the user types. So let's do that again, right? We can say is yes. Are you and your spouse both over 65? That allows us to get rid of these lines of code. The next question is your combined gross income more than 30,000? So is yes. I'm just gonna actually grab this question and dump it in here. And don't forget to pass in the scanner input. Okay. Okay, so that took care of those errors. Let's keep going. So if is yes, is one of you over 65? So we can now get rid of that. If is yes, is your combined gross income more than 27,000? So we can get rid of that. Again, if is yes, is your combined gross income more than 25,000? We can get rid of that. And then we'll do the same down here. So if is yes, are you over 65 years of age? We can get rid of that. If is yes, is your gross income more than 27,000? And last but not least, if is yes, is your gross income more than 24,500? And we can get rid of that. Okay. So we wrote a method that asks a question. It returns true if the answer was yes, and it returns false if the answer was no. Because we wrote that question, that method, we can now use it, and we've cut down the number of lines in our main method. One thing I want to say is, as I was converting my code, as I was refactoring it, and I was replacing those 3 lines of code with one method call, there was a lot of imbalanced parentheses happening, right? Every time I typed is yes and I had an open parentheses, I had to remember to close that method call, right? I had to remember to put a closing parentheses. So one thing I often see with students is as they're refactoring their code, so they're like, wow, I can write a private method, right? And you're excited and you write your private method and then you go to call your private method. Oftentimes, because you have methods which have open and closing parentheses, and you have conditionals which have open and closing parentheses and open and closing curly brackets, something gets out of balance. You've opened something and you didn't close it, or you closed it one too many times, and it can get really confusing. So the 2 things I'm going to say are go slow. Don't take any shortcuts. And 2, that's where the colors from BlueJ will come in handy. If you forget one of these, okay, well, also errors. Errors just help you. So if I had forgotten one of these closing parentheses, right, I have an error. Let's say though that I had forgotten, right, a closing curly bracket, you can already see, or you can immediately see that the coloring in BlueJ gets off, Okay, so you should use the color of your code to kind of your advantage to help you identify where you're missing a bracket or parentheses. So it can get very hairy, you have to be careful. Okay. Okay, that's great. We have this method. It is a private method, and we'll talk about that at the end. Okay, I want you to do the same thing now. I want you to, I claim there's still more repetition. So I want you to, once again, pause the video, look at this code, identify what is an additional chunk of code that is being repeated again and again and again and again. Okay, and then we will try to make a method for that. Okay. Okay. For me, looking at this, I think the next piece of repetition that jumps out at me is this innermost question here. Is your combined gross income more than something? If so, yes, else no. Okay, so that repeats once, twice, 3 times, 4 times, and 5 times. And it's not exactly the same. Notice that the income threshold is changing each time, but that logic, what's your income? Yes, no. What's your income? Yes, no. What's your income? Yes, no, is repeating again and again and again. So for me, my next thought would be like, let's pull that out into a private method. Okay, so thinking about that a little more, what would this method do? It's gonna be a method where we're gonna ask a question about your income, and the income threshold is changing. So that's probably gonna be an input. You tell me what the income threshold is. That's an input to the method. Then using that income threshold, we will ask the question and we will either print yes or no. Okay, so let's see if we can write such a method. So private static, this method is not gonna return anything back. It's in this method that we're doing the final decision. Yes, you must file, no, you must not. And so there's not really anything we need to return back. So this is gonna be a void. Let's call this final question. And we're gonna take in, and here you could take in an integer if you wanted to. I'm gonna take in a string, what is better? Should we take in a string 30,000 or the number 30,000? It doesn't really matter. Let's do an integer. So integer income. Oh, I guess we also need the scanner. So we are going to ask them a question. So we're going to need the scanner so we can read their input. Okay, so the first thing this method is going to do is we're going to ask a question. So we're going to say, if it is true, okay. So even I'm having to stop to kind of figure out where does my method begin and this method call end? Okay, so close the method call. So that's that parentheses. Close the if statement. Else, there we go. Okay, so here's kind of the high level structure of this method. So you will pass in the income that you're interested in asking about. Then we'll ask, is your gross income more than this amount? If the user says yes, this method will return true. We will enter inside the if statement, and then we'll print system.out, yes, you must file taxes. If the user types no, their income is not greater than that threshold, we will jump to the else and we'll say, no, you do not need to file taxes. Okay. Note that our method final question depends upon our method is yes. Okay, so once we write this method is yes, it's not only useful to us in our main method, it's actually useful to us in other methods, right? It's such a useful method. It's such a general thing you want to do. I want to ask a question and know what the user said, right? And so one of the really sweet things about pulling out repetition and putting that repeated code into its own method, one of the really sweet things is When you get a good method, you know it's a good method because you use it all the time. And there's just a sense of satisfaction inside, like, yes, that's why I made the method. It is super useful and I'm using it all over the place. Life feels good. Okay, so we see that happening here. It's such a useful method that even inside a final question, we're actually calling is yes, because I want to ask a question, right? So that feels good, looks good. Okay, so now that we have our other method, final question, let's go through, simplify our code even more. We can get rid of all of this, right? And instead we can just call the method final question, pass in 30,000 and our scanner, and we're done. And here as well, get rid of all of that. So final question, 27,000 and scanner. Here as well, just get rid of all of that. Final question, 25,000. Pass in our scanner. We're done. And then going down here, once again, get rid of all of this. Right. So final question. Oh, I didn't see what that was. What's the threshold? 27,000. Okay, that was close. Okay, final question. 27,000. Pass in our scanner. And last but not least, final question. 24,500. Pass in our scanner, and we're done. And there we go. So we started with the main method that was 78 lines long. We couldn't even put it on one screen. With the use of private methods, bam, pretty short. Yeah, you should just sit there and just feel good about that. It feels good. So here's our final code. If they are married and if they are both over 65, we ask our final question with a threshold of $30,000. If they're not both over 65, we ask, is one of you over 65? If that's true, here's the threshold income, 27,000. Otherwise, it's 25,000. Going back here, if the person is not married, they're single. If they are over 65,000, we ask our final question with a income threshold of 27,000. Otherwise, it's an income threshold of 24,500. Pretty sweet, tight, concise, and looking good. Okay, the last few comments I want to make, I actually would pull this out as well into a method, not because of repetition, but just for, I guess, organizational sake. Yeah. Last but not least, okay, what is this whole private thing about? Why were these not public methods? Okay, let's compile. That's kind of the moment of truth, a little nerve-wracking. And let's run this. Okay, so let's run tax helper. Here it is. When I right click to run, notice the only method I'm allowed to choose is the main method. Okay, previously when we created methods, they were always public, public static, public static. And when we right clicked, it would show us all of the public methods. It doesn't make sense though to allow someone to run, for example, the is yes method. Like you can't just independently run that method. And we shouldn't allow the users of our program to simply independently run the final question method. It just doesn't make sense. So for people using our program, the only method we want to allow them to run is the main method. And it is the main method that will call behind the scenes the is yes and final question. That is the purpose of the private keyword. The private keyword means this method can only be called. In other words, this method can only be executed from inside the tax helper class. So it is only methods inside the class, right? Between this open curly bracket and this closing curly bracket. It is only within the class that we can actually execute these methods. But from outside of the class, so here, those methods do not exist. They are private and internal to the class. From the outside, the only thing you see are the public methods. Okay, so let's run the main method. It's our only option. Okay, welcome to the Tax Center. Are you married? Please type yes or no. Oh, I am. I'm married, so yes. Are you and your spouse both over 65? No, we are not. Is one of you over 65? No. Oh, no. Is your gross income more than 25,000? Praise God, it is. Yes. Yes, you must file taxes. Okay, let's do that one more time because most of you are not married. Okay, so I will answer on your behalf. Are you married? Probably not. I have had some married students, but mostly the answer is no, so no, you're not. Oh wait, are you married? No. Are you over 65 years of age? Probably not. Is your gross income more than 24,500? Probably not. No, you do not need to file taxes. Okay, let's run this one more time and just see what happens if I disregard the instructions and I just say, I type like Y with a capital S. Are you married? Yes. Are you over 65 years of age? Yeah. Is your gross income more than 24,000? Yeah. No, you do not need to file taxes. Okay, so if you kind of answer however you want, so we specifically in our code tested for lowercase y-e-s, and anything else is a false. So despite saying yes, inside our code, we're saying false because you did not type lowercase y-e-s. So in our flowchart, you actually followed this path. No, no, no. Okay. Okay, here is kind of what I called Better Tax Helper. This is the version of our code that incorporates all the changes we talked about, and I decided to make a private method for the greeting. Looking at our main method is now 26 lines long. Okay, so we went from 78 lines long, had to scroll through all of this nesting all the way down to 26 lines. Okay, so that's kind of one of the benefits of private methods. It keeps your code tight, concise, organized, much easier to read, and all of the repetition gets pooled out into one private method. Another benefit, and I talked about this before, if we had, I mean, we don't, but if we had a bug or an error in our code here, right, we only need to fix it in one place. But if we had copy and pasted and we had this repetition, right, we would have so many errors in our code. Okay, so by pooling out repeated code and having it appear just one time in a private method, the bug appears only one time and you only have to fix the bug in one place. Okay, so it makes your code more error safe is a way to say it. Okay, that's it. Okay, so going back, I want to finish this by talking about the benefits of private methods. So as I said, but here I'm writing it, private methods can only be invoked or called or executed from inside the class, from within the class. If you are calling a method from a different class, so you are outside of the class and you're calling a method that is private, it doesn't even show up. You are not allowed to do that, okay? And I think that even matches the English meaning of the words public and private. Public means it is out there for public display. Private means it is personal, it is private, and it's kept hidden, okay? Some of the benefits, private methods eliminate repeated code. They support the other methods, right? Our private methods were supporting the main method. The main method is where the heavy lifting was happening. The private methods were supporting that. And as a benefit, it allowed us then to keep our main method very short, very concise, and very organized. That's that. Okay, so let's do a quick recap. So going back, we started by talking about nested conditionals, which are not a new type of conditional. It's just a way of using the conditionals we talked about last time. Namely, you can nest them. Here's an example of nesting, and we kind of have two layers. We have the outer conditional, and then inside we've got another set of conditionals. And at some point, stop doing that because it just gets hard to read. So here's an example of using nested conditionals to find the minimum of 3 numbers. Again, you can solve this problem in a bunch of different ways. Here's another way of using nested conditionals, but having multiple return statements. Or we could get rid of nested conditionals altogether and simply have more complicated Boolean expressions. Next, we looked at the tax helper, implementing this flowchart, and I think it's interesting how the structure of this flowchart almost directly translates over into the structure of our code, which is really nice. Looking at our code here, we saw that we could have a really long main method, or we could notice there's a lot of repetition. Every time you see repetition, you want to pull that out into a private method. It's not always easy. You do have to sit there and think, okay, what inputs do I need for my private method? What outputs, right? What's the return value of this private method? And then you have to go through and refactor or update your code. And again, be careful of your parentheses and your curly brackets. It can get a little hairy. But you know you have a really sweet private method when you're using it all the time, and it's just super useful, and it's a very useful tool. You just can't help but feel good inside. Here we cut down our code tremendously, from 78 lines all the way down to 26 lines. That is often the side effect of effectively and appropriately using private methods. And then last but not least here, this is me just summarizing the benefits. And again, definition-wise, what is a private method? It's a method that can only be called from within the class. From outside of the class, you can't call it. It is not for you. Okay, and I think that's it.